everyone. So today we're going to be going over lesson 2-1. It is the first section in chapter 2. So we're going to go ahead and get started with that. Again, pause the video as needed for notes and for you to give your chance to try the you tries. So we're going to go ahead and get started now. All right, so here we have relations and functions. That is our new lesson for today. We're going to go over how they're related and then what makes a relation a function and what makes a relation not a function. All right, so here we have the key concept here is we have a one-to-one function, an onto function, and then both one-to-one and onto. So pretty much any set of coordinates or pairs that we make are a relation of something, how it relates to each other. So we have that, and one-to-one would mean it is a function, and that means from every domain value, we only go to one range value. Onto means for every domain value, we go to a range value, but you might not have a unique range value. So the difference that we have here is that we have 3 goes to A, 2 goes to B, 1 goes to D. However, in onto, notice that both 3 and 4 both go to C. So that makes it not one-to-one. If it is both one-to-one and onto, it's a unique, we have a, each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. And this becomes very useful later on in the year when we start talking about inverse functions. But it's easy to see how it's one-to-one here. So let's take a look at our first example. We have state the domain and range of the relation and determine whether the relation is a function. If it is a function, determine if it is one-to-one, onto, or both, or neither. So here is our relation plotted for us. And so we're just going to list our coordinate points as 1, 2, 3, 3, 0, negative 0, negative 2, negative 4, negative 2, negative 3, 1. So when we're looking at this to see if it's going to be onto or one-to-one, if it's a function or not, the first thing we're going to check and look is at our x values. So I have 1, 3, 0, negative 4, and negative 3. Since none of the x values repeat, it's automatically a function. We don't have to worry about that. And then to check if it's onto, we're just going to see if they have any of the same y values. And then we see that they do have the same y values of negative 2. So it is onto, but it is not one-to-one. Because there is not every x value has a unique y value. All right, so here is your you try. Go ahead and give this a try. Before we go over it, state the domain and range of the function or the relation and show in the graph is the relation a function. So I'm going to give you a moment to pause and then we'll go over once you have finished. Okay, so here we have our coordinate points negative 3, negative 1, 0, negative 2, 2, 0, and 3, 1. Since there are no repeating x values, it is a function. So because of that, we can go ahead and cross out options C and D, because since there's no repeating x values, it is a function. So we can already answer yes to that part. Now my domain is just all the x values. So negative 3, 0, 2, and 3. Those are my domain. My range would be negative 2, negative 1, 0, 1. So with that, our answer is B. Right, moving on. Something you should probably recall from Algebra 1 is the vertical line test. It is also called a pencil test. It's where you take a vertical line over a graph to test if it's a function. If it only touches once as you go through the graph from left to right or right to left, it is a function. But if it touches more than once, it is not a function. So here's an example of it is a function. Here's an example of it's not, because it touches both here and here. All right, so taking a look at our example 2, we have the table shows the average fuel efficiency in miles per gallon for SUVs for several years. Graph this information to determine whether it is a representative of a function, if it is a function, or is the relation discrete or continuous. So the first thing we're going to go ahead and do is plot. So on our x-axis we have the years, so year 2001, 2002, and so on to 2007. On our y-axis, we have the miles per gallon. So we're just going to plot all our points. And we notice that actually between 2001 and 2002, the average fuel efficiency actually went down, which is interesting to see considering how we want fuel to be more efficient for us. And then after that, it steadily increased to more miles per gallon. And so when we do this, we're going to go ahead and use the vertical line test, and I can see there are no repeating x values, which would make sense considering our x values, our domain, are considered years, and usually we're only having, if we're having an average per year, you're not going to have repeat years. So yes, it is a function because the graph consists of distinct points and the relation is discrete. So discrete means it's kind of cut up, versus continuous, it would be a continuous line. So these are just bits and pieces, so that's why it is discrete. All right, next we have the table shows the average weight of a baby for several months during the first year. Graph this information and determine whether it represents a function. All right, so I'm going to go ahead and give you a moment to pause and give this one a try. Okay, so here we are. We're going to go ahead and plot our coordinate points first. So the first thing is I know is 1 is 12.5. So looking at that, they all look pretty good. So I'm going to take a look at 2. 2 is 16. So 2 is 16. So A works, C works, D works, and B works as well. So then we're going to jump to 4, and we're going to plot at 22. So A technically works for 6, no, for 4. So C is missing the point for 4. So A works, B works, and D does not work. So C and D are both missing the point for month 4. And looking at it, we can actually say if you finish plotting them, you'd either narrow it down to A or B. And because there's no repeating age here that we have, it is a function, so our answer is A. All right, so our next example is graph y equals 3x minus 1 and determine the domain and range. Then they want us to determine whether the equation is a function. Is it one-to-one, onto, both, or neither? State whether it is discrete or continuous. So the first thing we're going to do is going to make a simple table for the values of x and y. So when we do head and plug in -1 through 2, we find the y values are -4, -1, 2, and 5. We are then going to graph the ordered pairs. And because they do give us an equation that I could actually have between, I can actually ask, what about 0.5? And I would be able to plot that point. What if I wanted to plot, you know, -0.5, I'd be able to plot a point. So we are going to draw ahead and connect our dots by drawing a line. So since x can be any real number, there's an infinite number of ordered pairs that can be graphed. All the line shown, notice that every real number is the x coordinate of some point on the line. Also, every real number is the y coordinate of some point on the line. So that means our domain, so I can use any x value and any y value. So our domain and range is all real numbers. We might see that written a couple ways. You might see it with the fancy R. You might see it with parentheses and brackets, doing negative infinity to infinity. And you might see it written out as all real numbers. So those are a few ways you might see it. The other thing they wanted us to go ahead and describe was if it is discrete or continuous, as well as if it's onto one-to-one and so on. So the graph passes the vertical line test, so it is a function. It is one-to-one and onto, and since the domain and range are all real numbers, the relation is continuous. All right, so for your U-try number 3, go ahead and graph y equals 2x plus 5. I will give you a moment to go ahead and try that on your own. Okay, so let's go ahead and get started. The first thing I would do is draw a table of values. And so I would probably go with, we can do -1, 0, and 1. That should give me a good idea of everything. So if I plug in -1, we get -2 plus 5, which is 3. If I plug in 0, I get 0 plus 5, which is 5. And if I plug in 1, I get 2 plus 5, which is just 7. So I'm going to try plotting these points so I know I get 0, 5 is the first thing. And I'm assuming they're counting by 1 since they didn't give us a measurement. So I'm going to cross out D and C because it looks like they cross at 2. So this is at 2. So we're going to cross those out. -1 is at 3, which is here. So -1, 3 would be about here. So I can see that it's not going to be B, so my answer is A. And I should have looked, when I looked at plotting 1, I did choose that because I did have a few where they had the positive x values picked. That's how we can go ahead and do that. All right, moving on. Here we have example 4a, given that f of x equals x cubed minus 3, find f of -2. So a couple of things just to know. Here we have f of -2. So this is what we call function notation. You may have heard of it before, but I'm going to briefly review it in case you forgot about it. So when I see f of -2, all that really means is, what is y? When x equals -2. So this is just saying, using function f, my input is -2, what is my output? So it's going to be input -2, and what do you get? So I'm going to head in, that means we're just going to go ahead and substitute the value of -2 for every x we see in our function. So this is also a good reminder to always go ahead and use parentheses, especially when we're using negatives. Over here, we're just saying we're inputting -2. We are not multiplying over here. This is just a notation for us to use. So when we go ahead and simplify, we're going to do -2 cubed. So that means we're going to do -2 times -2 times -2. And if you need to see this written out, that gets us 4 times -2, which gets us -8. So that's how they get the -8 here, minus 3, which is equal to -11. So that means f of -2 equals -11. We are not limited to only inputting number values. We could also put in our own expression. So here they have the expression 2t in as the input. So we're saying f of 2t, which is going to be the same thing, that everywhere I see an x, I'm going to input 2t. So we substitute 2t in. So I'm going to do 2t cubed. So that means I have 2t times 2t times 2t. So if I do these two here, we get 4t squared, because 2 times 2 is 4, t times t is t squared. Multiply that by 2t. 4 times 2 is 8. T squared times t is t cubed. And then we didn't touch the 3, so 8t cubed minus 3. And that would be our solution. All right, here is your u-try. Go ahead and determine f of -1 given that f of x equals x squared plus 5. I'll give you a moment to go ahead and try that, to pause the video so you can go ahead and try it on your own. All right, so we're gonna this just says to plug in -1, so we're gonna do f of -1 equals parentheses -1 squared plus 5. So again, this is the kind of work you should show when you're working the problems out. You need to show that you are substituting values in. So I can just bring down the equal sign. -1 squared gets me +1 plus 5. +1 plus 5 is 6. So my answer is D. All right, and here is another u-try. F of x equals x squared plus 5. Find f of 3a. So I'm going to give you a moment to pause it so you can go ahead and give it a try on your own. All right, so we're going to go ahead and write f of 3a equals, everywhere I see an x, I'm going to put a 3a, so we're going to do parentheses 3a, and then squared plus 5. So 3 times 3 is 9, a squared is a squared, plus 5. There is no like terms for me to combine, so our answer is D. That is the end of the notes. Do make sure you have some stuff written down in your notebook. And we will go over more when I see you in class. See you next time.